Today we're going to talk about Matt Dunning. You can tell it's him by the brim of the hat here. And Matt's favorite Yankee umbrella. You guys didn't know Matt had a favorite Yankee umbrella. Well, there's something you should know about Matt and his favorite Yankee umbrella. Do you know what that is? And that's the following. If it's raining outside, Matt puts his umbrella. So if it rains, Matt puts up his umbrella. So Matt looks outside. He sees it raining, so guess what happens? If it rains, then Matt puts up his umbrella. And that statement is always true. That is a true statement. Now, using that information, we could try to make some other conjectures about statements that might be true. Let's look at the first one, which is known as the converse of a statement. A converse is where you flip the if and the then part. I'm going to write it down in orange. Hold on. If Matt puts up his umbrella, it is raining. That is the converse of the statement. And the question is it always true? Well, the answer is no. Matt putting up his umbrella doesn't make it rain outside. For example, let's just say it was a beautiful sunny day outside, and Matt was concerned about getting too much UV on his delicate skin. He might put his umbrella up to protect him from the shade. So the converse is not necessarily true. Let's next talk about the inverse of that statement. If Matt does not put up his umbrella, it is not raining. I just negated both sides. Is that necessarily true? Well, no, not necessarily, because it could be the same condition as the other one. Maybe he didn't go outside. Maybe he just didn't put up his umbrella. But it is not. It doesn't necessarily have to be that relationship. The only one that has to be true is something known as the contrapositive. Let's take a look at that on the next page. Okay, here's our original statement. I just broke it down to an if P then Q statement, and we said that that statement was definitely true. We said that the converse, just flipping the two portions of the argument, would not necessarily make it true. If we negated both sides, making it the inverse, it would not necessarily make it true. But if we combine both of these things together into what's known as the contrapositive, then our statement is always true. And for this one, it would be if not Q, then not P. You switch the arguments and you negate them. So for Matt, our statement from before, where of if it rains, then Matt puts up his umbrella,